All right. Next one, are the following equivalent? I have a plus b squared and a squared plus b squared. All right, so a plus b squared, I want you to remember, okay, is really a plus b times a plus b. So if you were to see this question on an assessment, all right, you need to tell me that a plus b squared is really this, okay, which means that that's a squared plus ab plus ab plus b squared, or a squared plus 2ab plus b squared, which does not equal a squared plus b squared. A counterexample, people, okay, I would say put in 1. Put in, not 1. 1's not a good example. Actually, 1 is a fine example. If I do 1 plus 1, that's squared, that's 2 squared, which is 4. If I do 1 squared plus 1 squared, that's 1 plus 1, which is 2. 4 does not equal 2. Therefore, they're not equivalent. What would that say? Like, you're squaring this entire thing. I'm squaring all of a plus b. I'm not squaring each of them individually. Determine if the given value is a solution to the equation. X equals -1, so I'm going to plug that in and check it out. 3 times -1 minus 7 equals -5 times -1 plus 3. 3 times -1, -3 minus 7 gives me -10. -5, -1 plus 3 is 2. -10 equals -10. That checks out. This may be a true or false question on the assessment. Okay, we'll see. All right, so I realized, I was looking at this problem. Okay, and I realized I don't really need an algebraic equation to do this one. All right. During his morning forecast, the weatherman predicted it would be 17 degrees Fahrenheit. In the 5 p.m. news, he comments that his prediction was 3 degrees higher than the actual temperature. Than the actual high temperature. What was the actual high temperature for the day? Well, if he comments that his prediction was 3 degrees higher than the actual temperature, then I'm just doing 17 minus 3, so it's 14 degrees Fahrenheit. There actually is no algebraic equation you could write for that. I tried to think of one, and it'd just be way too confusing, so just 14 degrees Fahrenheit. Suppose a class has 30 students, and suppose a class of 30 students has 5 students that do not have a writing utensil. How many students would not have a writing utensil in a class of 12? So in this case, I would just set a proportion. 30 students in the class, 5 without it, equals 12 students in the class. How many without it? And then I can cross multiply here and solve. 30 times x, 30x. 5 times 12 is 60. Divide both sides by 30. X equals 2 students. That was not too bad. I'm going to do one more, okay? Do the following lengths form a right triangle. So remember, our test for right triangle is the Pythagorean theorem. So I need to test that out. Does 6 squared plus 8 squared equal 10 squared? Well, 6 squared is 36, plus 8 squared is 64. Does that equal 100? Yes, it actually does. So that checks out. So this would be a yes. All right, now for part B, same idea. 10 squared plus 24 squared, does that equal 26 squared? Well, 10 squared I know is 100. 24, I forget what that is. 576, that's right. 100 plus 576, and then 26 squared, I have no idea, is 676. So in this case, 676 equals 676. That checks out. This is another yes. So they both do. Some more values. All right. I'm going to keep going. 7 squared plus 8 squared equals 24 squared. 7 squared is 49 plus 64. And 24 was 576. I can tell you right now that this does not equal that. So this would be a no. I mean, you can't. 49 plus 64 is not going to get you 500. All right, let's keep going. Why not? We're having fun. I can tell. I can see in your face. Last one, then I'll pause the video. 18 squared plus 80 squared. Does that equal 82 squared? These are a lot of big numbers. 18 squared is 324. 80 squared is going to be 6,400, right? Yeah, plus 6,400. 82 squared is 6,724. Well, if I combine over here, these check out. So this is another yes. All right, pausing it here.